Thank you for joining this lesson. We're going to discuss Mathematics Paper 1, the Kcse 2024 examination. You can share the link. You may invite your friends. Remember to subscribe. Remember to comment. Yeah, so this is the paper. We go through the paper question by question, and I believe you people are going to really benefit from the live broadcast. Kindly invite somebody. Remember to share. Anybody in secondary school is able to understand Mathematics Paper 1. Most of the areas will be coming from the lower forms. So this is what we'll be discussing. Yeah, question number 1. Without using mathematical tables or a calculator, evaluate 0.13 multiplied by 0.3 minus 0.003 divided by 0.09, giving the answer in decimal form. Strictly giving the answer in decimal form. So let's look at the possible solution to this question. Let me begin by sorting out the numerator, whereby I'm supposed to apply BODMAS. I can see there is multiplication and also there is a minus. So we begin by the multiplication, whereby 0.13 by 0.3 becomes 0.039, then minus 0.003. We can now simplify further by subtracting, and we will get 0.036. So now we are having the answer from the numerator. Then from this now we can combine. We can combine now such that we need the numerator in the simplified form, 0.036. We divide by the denominator, which is already simplified. So you can see now the numerator is 3 decimal place, the denominator 2 decimal place. So we can do away with the denominators, with the decimal places, that is, by ensuring that in both sides we multiply by the highest number of decimal places, which is on the numerator. So we can multiply by 1,000 to have the numerator becoming 36. Then the denominator will become 9, but there will be an extra 10, because whatever multiplies the numerator must also multiply the denominator. So this will be 4 out of 10, but remember we are to leave it as a decimal place. So 0.4 expressed as a decimal. So that is the answer for the first question. Let's continue following. We are now in number 2. Simplify the expression. So we got some expressions here. The first expression, which is on the numerator, is what we call a difference of two squares. A difference of two squares because we have 4x power 2 minus 9. So they are both perfect squares. Yeah, they are both perfect squares. So now I'll be talking about the numerator's simplification. We know very well to simplify a difference of two squares. Let me give this the general simplification. X being squared minus y squared. To simplify this, we need to take the square root of x minus the square root of y. Then the same roots now, but with an addition. So now that is how generally a difference of two squares should be simplified, which means the numerator is going to become the square root of the first part, 2x, minus the square root of the second part, 3, then the same square roots, but now with a positive. So now the numerator is fully simplified, or rather factorized. Let's look at the denominator. The denominator is a quadratic expression, as we can see. Yeah, the denominator is a quadratic expression whereby we need to simplify it. And allow me begin by saying that we need to take two factors, which when multiplied, they will give us a times c, which is a 2 by -6, giving us negative. And the sum equals to the value at b, which is just 1. So these two factors are going to be 4 and 3. When multiplied, 4 at -3, sorry, 4 at -3. When multiplied, they give -12. When added, they will give us +1. So now we can replace b with the two factors, such that 2x squared plus 4x minus 3x minus 6. Yeah. Now we can factorize from the first two terms. We factorize whatever is common, and that is 2x. So that will remain with x plus 2. Yeah, x plus 2. Sorry for the interruption. Yeah, x plus 2. Then minus 3 is common. So that will remain with x again plus 2. So now we can pick the common factor in the brackets, x plus 2. Then from outside the brackets, we will have 2x minus 3. 2x minus 3. Now at that point, allow me combine the numerator and the denominator. Because we have both factorized forms, now we can combine numerator and denominator. So 2x minus 3, 2x plus 3 divided by x plus 2, 2x minus 3. So that is the combination. And we can see that some of the factors are now common, like 2x minus 3, 2x minus 3. So that cancels out, and we shall remain with the final answer as 2x plus 3 out of x plus 2. So that is the simplified answer for question number 2 in the Kcse 2024 examination. Remember, revising Kcse 2024 is also part of preparation for the Kcse 2025. Remember you can even comment. Let us know where you are following us from. Like, subscribe if you've not subscribed to this platform. Ensure that you're working together with us, even as we continue bringing more lessons to you people. Here we go to number 3. I hope you people can also see that our consultation line is on the board, 0704 15 3366. So that is the line you should consult through. As we continue learning, it's good I remind you of our program here, whereby you can purchase airtime for all the networks, be it Airtel, be it Telcom, be it Safaricom. Just go to the M-Pesa menu, Lipa na M-Pesa, then you enter the pay bill number 737356. Then the account number is the phone number that you would like to purchase airtime for. Pay bill 737356. Account, the phone number that you'd like to purchase airtime for. Then you proceed with the transaction, and through that, the airtime is going to reflect instantly. So please utilize this facility and invite your friends to utilize the same. Number 3, a straight line L1 whose equation is y equals to 2 minus a third x meets the y-axis at Q. Meets the y-axis at Q. Another straight line L2 is perpendicular to L1 at Q. Find the equation of L2 in the form y equals to mx plus c, where m and c are constants. Where m and c are constants. So let's look at the solution again. Allow me go to the equation of straight line L1 and I rearrange it such that L1 now becomes y equals to, instead of beginning by 2, I begin with negative a third x, then the 2 comes here. This way, the equation is in the form y equals to mx plus c, and from such an equation, we can draw some conclusions about it. For example, gradient for line 1 equals to negative a third. Something else that we can draw is that the y-intercept for this line, is 2, because with the general equation y equals to mx plus c, then we usually know that the gradient is the value of m and the y-intercept the value of c. So if the line cuts the y-axis at a point where y equals to 2, then it means the coordinate at that particular point, which now becomes the coordinate of Q, will be 0, 2. Reason being, at the y-intercept, the value of x is usually 0. So that one goes without saying. Along the y-axis, the values of x are usually 0. So at a point where the line is cutting the y-axis, automatically the value of x is 0, and through that we can draw a conclusion that the coordinate of Q is 0, 2. Now, we are told that another line L2 is perpendicular to L1. Being perpendicular to L1, then we can get gradient of L2. Because we have gradient 1 as negative a third, then gradient 2 is going to be the reciprocal with the opposite sign, and that is 3. The reciprocal of negative a third is 3, but now we need 3 with the opposite sign, such that when we take gradient 1 and we multiply by gradient 2, then we get exactly 3. Yeah, we get exactly 3. Now, for equation L2, we have the gradient, and we are also having, we are also having the y-intercept. This one now, so that I may not lose some people along the way, allow me express gradient and say that gradient is given by change in y. So when we take y minus 2 divided by change in x, x minus 0. Change in x is x minus 0. Then now we cross multiply to have y minus 2 equals to 3x. Remember, x minus 0 just remains as x. Yeah, it just remains as x. Then now we can talk of y equals to 3x plus 2. 3x plus 2. So this is now the equation of L2 in the said format. The equation of L2 in the said format. So allow me also say that there is a way we can find the equation just directly. Alternatively, a sharp student can claim this. A sharp student can say that in the general equation, y equals to mx plus c, the value of m is usually the gradient, the value of c is usually the y-intercept. This means that the equation can be written, because we know gradient to be 3, then we just insert 3 there, plus the y-intercept is 2, because if the line is perpendicular to the first one at the point Q, then it means it is also cutting the y-axis at point Q, where the value of y is equivalent to 2. So you can also go directly to the equation like that. We are still progressing with the paper. Now at number 4, at number 4, whereby you're being told that a circle of radius 3 centimeters passes through all the vertices of a regular hexagon. Determine the area of the circle that lies outside the hexagon. So we are having a circle. I'm just trying to sketch the information. We are having a circle, like that. Then what happens in this circle is that now there is an hexagon. You know, an hexagon is a 6-sided figure. An hexagon is a 6-sided figure. So there is an hexagon in this manner. The hexagon now is inside the circle. This is just a sketch of the information. Yes. Now that is how things are. We are trying to find determine the area of the circle that lies outside the hexagon. So outside the hexagon, there is some area. This is circle lying outside the hexagon. Circle outside the hexagon. Circle outside the hexagon. Yeah, that is the area that we want to calculate. So what we're supposed to know here is that because the radius of the circle is 3 centimeters, then to the center, we can now connect and say now we have radius 3 centimeters, 3 centimeters. Then the angle at the center now that in an hexagon, we can subdivide into 6 equal triangles, then we can get the angle at the center. The angle at the center is going to be 360 over 6 of them. Because we can subdivide an hexagon into 6 equal triangles, because it is regular anyway. Yeah, it's regular. Then we can divide the angle of 360 at the center by 6, so that we are having 60 at this point, 60 degrees. So now we can now extract a triangle or even a sector. Then we say, there are 2 possible approaches here, and we can use both actually, whereby we can say we need area of circle minus area of hexagon. Exactly. Area of circle minus area of hexagon. That will give us the area lying outside. So area of the circle will be pi r squared. Pi r squared. Pi r squared. Then minus area of the hexagon. So area of this hexagon now shall be, area of an hexagon, we need one triangle. Half times A times B, the sine of 60, that is one triangle, but now there are 6 such triangles. So this will be 28 and 2 over 7 minus 23.5. 23.38. 23.38. So this exactly will give us 4.903 cubic or square centimeters to an accuracy of 4 significant figures. Alternatively, the question is already done, but alternatively, what if a student takes the sector, then we calculate the area of a minor segment. Area of a minor segment is given by sector minus the triangle in it. Sector minus triangle. So the sector will be 60 over 360 pi r squared. So area of the sector, then we subtract area of a triangle. The triangle will be half 3 by 3 sine 60 degrees. Yeah, sine 60 degrees. So let's compute these values. We need 60 by 22 by 3 by 3. Then we divide by 360 multiplied by 7. And this will give us a 4.714. Then minus area of a triangle, 0.5 by 3 by 3, the sine of 60. This will be 3.897. So now we need to take 4.714 minus 3.897. This is going to give us exactly 0.817 square centimeters. But now this is area of one minor segment. One minor segment, whereby we have taken area of a sector minus area of the triangle inside that sector. So now with this minor segment, we need to multiply it by 6 such segments. 6 such segments. So by 6, I'm getting exactly 4.902 square centimeters. So because of round of errors, the values might slightly differ with the value from the first option, but generally it's a very legit approach which a student can apply and find himself in the answer or herself. Yeah, we can go to number 5 now. Number 5 is on indices. Check here. As you continue following, I am reminding you of our program here, whereby you can acquire airtime from your M-Pesa for any network, Safaricom, Airtel, Telcom. Just go to the M-Pesa menu, Lipa na M-Pesa. The pay bill number is 737356. As you can see it displayed there. Then the account number is the phone number that you'd like to purchase airtime for. Then you complete the transaction and the airtime is going to reflect instantly. The airtime shall reflect instantly. So please utilize the facility and invite your friends to the same. Let's now continue with number 5, mathematics paper 1, the Kcse 2024 examination. Solve for x in the equation. Solve for x in the equation 25x equals to 125 power 2/3, then divided by 5 power -1. That is the equation. So how do we get the value of x? In the first composite number, which is 25, we can express it to the minimum base possible according to the question. That is base 5. So it becomes 5 squared. But now there is already an existing power of x. So it becomes 5 power 2x. This is equals to 125. We also express it to the least base possible. That will be base 5. Then this is 5 power 3. Now power 3 finds 2/3 such that it is 3 times 2/3, which will make it just 2, divided by 5 power -1. Now on the right hand side, we can simplify further by applying a law of indices, which says in case we have a number raised to a given power divided by the same number to a different power, due to the division, we just subtract the indices. So on the right hand side, let me re-express now. 5 raised to 2x equals to 5. Then we have 2 minus -1. There, students must be very careful. It's not -1, it's minus -1. Because apart from the minus due to the law, there is a minus already on the power. So now that we have all the indices the same, we have the bases being the same, we can now equate the powers. So 2x is the same as 3, or rather 2 minus -1 becomes +1. So now we can remain with x by dividing 3 by 2, which finally will be 1.5, or simply 1.5. Yeah, you can write it as 1.5 or 1.5. Yeah, I can see junior secondary school teacher is commenting us. Great work, sir. Continue to empower the learners always. Thank you so much for following. I encourage the people who are watching us to kindly subscribe and also to leave a comment. Kindly let's know where you are watching us from. Let's know whether you are learning something. Let's know whether we are audible enough. Let's know how everything is fine. Otherwise, thank you so much for being around. Thank you for being some good supporters. For any queries, if you'd like to ask a question, you'd like to get the revision papers, you can feel free to use our number on the board, 0704 153366. So that is the number that you're supposed to use. Now we continue. Yeah, let's continue. In number 6, we are told that a carpenter had 2 big pieces of wood of equal lengths. The carpenter cut the first piece into smaller pieces of length 15 centimeters each without remainder. The carpenter cut the second piece into smaller pieces of length 24 centimeters each without remainder. Determine the minimum length of each of the big pieces of wood. So now it's a big wood, or it's big woods being sliced into smaller ones. And we said in this case, it means that that is a multiple of whatever we are having. In case it was a bigger woods being cut, then we would have gone for divisors. But in this case, now that we need a multiple which has all these lengths, then we go for what we call the LCM. The wood is greater than the dimensions provided here. The dimensions of the wood that we need is greater than the provided dimensions of the pieces provided. So we get a multiple, which is the LCM. The LCM of 15 and 24. So the LCM of 15 and 24 can be calculated very easily. You can get the prime factors making both 15 and 24. We begin by 2, 15, 12. By 2 again, 15, 6. By 2, 15, 3 by 3, 5, 1. Then finally by 5, 1, 1. Therefore, the LCM is going to be 2 power 3 multiplied by 3 multiplied by 5. And this is going to give us exactly 120 centimeters. So the pieces of wood were measuring 120 each. 120 in each case. Yeah, 120. Let's look at number 7. We are told that a cylindrical container of internal radius 10.5 has a hemispherical base. The container has water up to a height of 30.5 centimeters. Calculate the surface area of the container that is in contact with water. Right, this is a good question whereby I would encourage an average student not to attempt without doing a sketch. Let's sketch. Diagram sketching is a concept that helps learners to show that they are understanding the instructions provided and they can comprehend what is happening. So when you put these statements into a diagram, that is an indication that you can understand what is being transacted in the question. Let's do the sketch. Cylindrical. Then we are told that the base is not just a cylinder, but an hemisphere. The base is hemispherical. Look at the sketch. So apart from the cylindrical part, now we will talk about an hemispherical base like that. So this is how the container looks like. This is how the container looks like. Now we are told that the radius is 10.5 centimeters, and it is having water up to a height of 30.5. So what we're supposed to know is that from the base up to where the hemispherical part is ending, there is a length equivalent to the radius of the hemisphere, which is also the radius of the cylindrical part, and that is 10.5. And if water is up to a height of 30.5, then there remains a height of 20. There remains a height of 20 centimeters. So that the total height of water becomes 30.5. Then there is the radius of the hemispherical part, then an extra height on the cylindrical part now, which will be equivalent to 20. Now, for us to get surface area, we need a surface area of the hemispherical part, then plus surface area of the cylindrical part. For an hemisphere, we know that surface area, we need total surface area, which will be given by hemispherical part 2 pi r squared plus the cylindrical, which is 2 pi r multiplied by the h, or rather the height. So we need 2 by pi, 22/7, multiplied by a radius of 10.5, then we square. Then we add 2 multiplied by pi, multiplied by a radius of 10.5, then multiplied by a height of 20. Yeah, the height is 20. So the two values that we're going to get from such a case are 693 from the first case, hemisphere, plus 1320 on the cylindrical part. And the total surface area will be 2013. Square centimeters. 2013 square centimeters. So that is how we handle such a question. That's how we handle such a question. Yeah, remember you can access airtime from your M-Pesa to any line by going to the M-Pesa menu, Lipa na M-Pesa. The pay bill number is 737356. Account is the phone number that you'd like to purchase airtime for. Then you proceed with the transaction, and through that you will receive your airtime instantly. Remember also to comment on our lessons. Remember to subscribe. Remember to share so that you may invite a friend. Let's look at number 8. This is a question from geometry and construction. In the following figure, points A and D, just as you can see them, are vertices of a trapezium ABCD. Line DC is parallel. Line DC is parallel to AQ. Then again, line DC is equivalent to line DC is equivalent to 4 centimeters. Yeah, I hope we are together in that. It's equivalent to 4 centimeters. Then we also told that point B lies on the line. Point B lies on the line AQ, such that the angle DCB equals to 90 degrees. Let me show you quickly what we're going to do so that we may handle this question. To ensure that DC is parallel to AQ, we can transfer the angle at Q. The angle here, we transfer it on the upper side of D. When you measure it there, then you produce a line. Then, yeah, you measure the angle here. Then automatically, the line produced at this point is going to be parallel to AQ. Then along that parallel line now, you measure your 4 centimeters. So once you measure 4 centimeters, we're also supposed to know that, remember, C is along line AQ, somewhere along line AQ. That means, okay, not C, but B. B is somewhere along AQ. Then we have gotten our C. Yeah, DC equals to 4 centimeters. Then now we should know that the angle at C, according to the instruction there, is 90 degrees. So from C, we shall drop a perpendicular to AQ. We drop a perpendicular to AQ. So we stand at C. We make arcs at these points. Then using those arcs, we also make other arcs at this point, such that now, if you drop this line now, then you are going to have our 90 degrees there, and automatically this will become our point B. So this is now the trapezium. Yeah. So we have completed the trapezium. So that is how you're supposed to do it. Number 9. Let's look at number 9. The question says that the length of a minor arc AB of a circle center O is 10 centimeters. The arc AB subtends an angle equivalent to 1.25 radians at the center O. Calculate the area of the minor sector A or B. 3 marks. Area of the minor sector. So what we're supposed to do is that there are several conversions here required. We need to know the radius of the circle, that's unknown, and we also need the angle at the center in degrees. So let's know the angle first. We can begin by knowing the angle, and it can be done using several methods. We can say that 180 degrees is usually equal to pi radians, which means 1 radian is equivalent degrees. Yeah, that is the value of 1 radian. That means we also, from the same, can calculate the equivalence of 1.25 radians. So this is going to be 180 out of pi multiplied by 1.25. And this is going to give us, an angle equivalent to 71.59. Yeah, 71.59. Now with the angle, and we are having the arc length. With the angle and we are having the arc length, then we can find the radius of the circle, whereby we say arc length is usually given by theta over 360 to pi r. R is unknown. And if we are to remain with r on one side, then it will become 8 centimeters. R is 8 centimeters. With r as 8 centimeters, then we can talk of area of the sector, which will be theta divided by 360 pi r squared. So this is going to give us now area equivalent to approximately 40 square centimeters. Alternatively, there is a simpler way we can follow this. Alternatively, there is a simpler way that we can follow for us to get the radius. Remember, in physics, uniform circular motion, and I think also in mathematics, that is a trigonometry 2. There is the definition of what a radian measure is. Radian measure is the angle subtended by the center of, 1 radian is the angle in radians subtended by an arc length, which is equivalent to the radius of a circle. So an arc length equivalent to radius of a circle subtends an angle equivalent to 1 radian. So we can now say that 1 radian would subtend an arc length equals to radius. Or we begin by the information provided that 1.25 radian produces 10 centimeters. 10 centimeters produces 1.25 at the center. What about 1 radian, which automatically produces the radius of the circle? So the arc length will be 10 out of 1.25, giving us exactly 8 centimeters. An angle of 1.25 is produced by an arc length equal to 10 centimeters, which means an angle equivalent to 1 proportionally will be subtended by 8 centimeters. And according to the definition of what 1 radian is, this is the angle at the center of a circle subtended by an arc length equivalent to radius of a circle. So the arc length producing 1 radian will be equivalent to the radius of the circle. So radius can be done in those two possible ways. Yeah, those two possible ways. Thank you so much for following. And see you are still watching. Remember to subscribe. Remember to share. Remember to invite a friend. The following figure, number 10, represents part of a pattern. A line of symmetry, L1, of the pattern is also shown. Complete the pattern and hence state the order of rotational symmetry of the patterns. So when you look at this, you discover that this is a shape, but the first one here is not complete. So let's start by finishing up the shape. So that's how the shape is. It's not a complete shape together with its image. Because we are being told it is rotational, we are assuming that it has gone through an angle until it is there. So if it goes through another angle, where will it be found? So it will be found at a point here. It will be found at a point here. Yeah. If it goes through the same rotation again, it will be found at a point there. And now it cannot make another rotation, because once it makes another rotation, it will go back to the first shape. So the shapes that can be displayed here now is only a total of 3. So the order of symmetry is exactly 3. If we would have made total shapes to be 4, then we would have said the rotational symmetry of the pattern is 4. If they remained only 2, such that by rotating 1, we'll get back to the first one, then it could have been 2. In this particular case, the order of the rotational symmetry is 3, because you can see 3 shapes which are similar. 3 shapes which are similar. Number 11, we are winding up. You can see people are following. Yeah, continue following, continue subscribing, continue sharing to invite friends to the live broadcast. Let's look at number 11. Number 11 is a question on commercial arithmetic, specifically currency exchange rates. A bank, or a Kenyan bank, bought and sold foreign currencies on 2 different days as shown. So we can see on 12th, on 12th January 2021, 1 South African rand was being sold at 7.10 after being bought at 7.0. Then on 12th February 2021, 100 Tanzanian shillings were being bought 21.12 and being sold at 21.25. A South African tourist arrived in Kenya 12th of January 2021 with 15,000 South African rands. He changed the whole amount to shillings. While in Kenya, he spent a total of 53,075 Kenya shillings and changed the balance to Tanzanian shillings before leaving for Tanzania on 12th February 2021. Determine in Tanzanian shillings the amount he received. Let's begin answering this question from the first part, whereby the tourist is coming from South Africa carrying South African rand. That is foreign currency. The acronym holds that foreign currency to Kenyan currency, we use the buying column. and this is by multiplication. For Kebu, foreign to Kenyan, we use the buying column. So we need a foreign currency of 15,000. We multiply it by the rate at which it is bought by the Kenyan bank, 7.08. So this is going to be exactly 106,200 Kenya shillings. Then while in Kenya, the tourists spend a total of 53,075. That means we need to know the balance now, which will be given by 106,200 minus 53,075, and this will give us a 53,125 Kenya shillings. So this is now the amount in Kenya shillings the tourist is having when going to the bank to claim some Tanzania shillings. So what happens to the bank? The tourist will buy Tanzania shillings and the bank will sell to him. So we have to go to the selling rate of Tanzania shillings. What you should know is that from Kenya to foreign currency, we have to use the selling column, and this will be done by division. This will be done by division. The table is giving us 100 Tanzania shillings being sold at 21.25, which means one Tanzania shilling will go for 0.2125 Kenya shillings. If 100 Tanzania shillings are being sold at 21.25, then one Tanzania shilling will go for 0.2125. Then now we will say the amount in Kenya shillings must be divided or should be divided by this selling rate, so that we may know the Tanzania shillings that will be received. And this is going to be exactly 250,000 Tanzania shillings. Wow. So from Kenya, you are having 53,000, and going to Tanzania, it becomes a 250,000. Yeah, so that is the rate of conversions. The rate of conversions. Yeah. So today we can look at the last question here, which is number 12. We are being told that the coordinates of points O, A, B, C, and O, A, B, and C are 0, 0, 2, 1, 4, 4, and negative 1, 7, respectively. The coordinates of a point B, which is XY, then point M is the midpoint of the line CD, and it satisfies the vector equation OM, this is vector OM, equals to vector OA plus 5 out of 2 vector AB. What we should write here is an expression of vector AB, whereby we need B minus A. And this is going to be RB is 4, 4, and A is 2, 1. So this will give us 2, 3. Yeah, that is the column vector AB. Column vector OA is just A from origin, then OM, the position of M from the origin. So vector OM will be given by OA, whereby we need the coordinates of A to 1, plus 5 over 2 vector AB, which is 2, 3. Yeah, vector AB is 2, 3. So this is going to be 2, 1 plus 5 over 2 by 2 becomes 5, and 5 over 2 by 3 becomes 15 over 3, which is a 7.5. So this is going to be 7 and 8.5. And this means that if this is the column vector of OM, then the coordinate of M shall be 7, 8.5. Now with the coordinates of M, and we are given instructions that M is the midpoint. M is the midpoint of CD. Look at this. Look at this. You're having C as the coordinate -1, 7. And we are having D as the coordinate dy. Then the midpoint M has now been obtained as 7, 8.5. Yeah, that is it now. So I think I've displayed it in a better way. Yeah, that is it. So with such a display, we should know that how do we get midpoint? Midpoint is usually given by the first x plus the second x. The x at C plus the x at D divided by 2. Then the y plus the other y also divided by 2. That's how the coordinates of a midpoint are obtained. So then we can say that the first x, which is a 7, is given by -1 plus x out of 2. This will mean 14 equals to -1 plus x. And to remain with x, we have to take -1 to the other side, 7 plus y. To remain with y, we subtract 7 from 17. That will be 10. So the coordinates of D, 10. Yeah, 15, 10. So that is it. We'll be continuing with the paper later. Remember to subscribe. Remember to share the link so that you may invite somebody to also watch the live broadcast. Remember to comment. Remember also to purchase airtime. Line which is working in Kenya, just go to the M-Pesa menu. Lipa na M-Pesa is 73 and the account number is the phone number that you'd like to purchase airtime for.